Hi, everybody. Today we're going to be talking about two different ways to calculate pi. They're both computational. So the first method is geometric probability, and the second method is the standard way of calculating pi. It's going to be perimeter circumference upon d, or diameter. Geometric probability, we have a square, and inside the circle, and random darts are going to be shot at the dartboard. The probability that it lands within the board is just the area of the square, d squared. The probability it hits is proportional to the probability it lands within the circle, and it's proportional to the circle. So the ratio of this is just pi upon 4, and pi in this case would be 4 times p c by p b. So we can calculate pi by randomly throwing darts and tracking how many fall in the circle. Here's the code. So we're using this in Python, and the animation package is called Turtle. So first, we're going to be generating a square, a circle, and then the darts. The random numbers represent the dart's location, and they're generated randomly as if someone with a blindfold was throwing them. We have a count that represents the total darts thrown, and the hit that represents the number of darts that are hit within the circle. We have a way to track the number of darts that actually land in the circle, and we have a way to calculate pi, which is just 4 times the hit by count. Now, let's see the code in action. So here's the square, and now we have a circle, and then all these darts are being fired. As you see, the more darts per 100, the closer it gets to 3.14, and it's at 3.15. I have to run this all the way to 1,000,000 to get a good approximation of pi. So now moving on to the next one. We're going to be using a hexagon in this example, but the whole idea is that we have a polygon, and we have a number of sides, and we get the angle. Now, we just use the regular formula, circumference divided by diameter, to get pi. For the case of the polygon, it's just perimeter upon diameter to get pi. As the number of sides increase, the perimeter of the polygon becomes a better approximation of the circumference. So that means that pi is the ratio p upon d. Let's have a look at the code now. So we're using the same animation package in software. And what we have here is the length of each side, the number of sides, and the angle of each side. And how we're going to get the ratio is the number of sides times the side length divided by the diameter of the polygon. We can calculate diameter by getting the opposite point and getting its distance from the origin. So now let's see this code in action. So here we have just the same software, and it's just making a square, and each time the number of sides increase, and it gets closer and closer to pi. So as you see, we're going to go until we have a decagon, and if you look at the numbers, each time we increase the side, it looks more like a circle, and pi becomes a better approximation. Now we are close to 50 sides of the polygon, and and the current value of pi is approaching 3.14. Right now it's at 3.15, and yes.